This is Introduction to Research Data Management. I am Alex Garnett. I am the Research Data Management and Systems Librarian at Simon Fraser University, and I've been working with Compute Canada mostly on the FERDR and Radium projects the past few years. My co-presenter
is Adam McKenzie, who's a Research Data Management Analyst at the University of Saskatchewan. I'm coming from a software development perspective, and I work with Alex too on Radium and FERDR.
So thanks for being here, folks, and we'll get started. Research data, we like to say, are any records created in the course of a research project. So anything that is produced over the course of academic research that is not the final publication, as far as we're concerned, is research data. That can be a lot of different things. In the humanities, it can be ephemera or audiovisual recordings. In the social sciences, it can be tabular data, ethnographies, etc. And in the sciences, usually it's high-resolution imaging output, big tabular data, and any other of several proprietary formats. The point being that all of this is data. It doesn't have to be openable in Excel or in a plain text format to be data. If it's research adjacent, if there's any value in recording it and capturing it, then as far as we're concerned, it is research data. Why should you manage your data? Kind of an obvious question, but for one thing, it helps you locate your files more easily. Our null assumption for unmanaged data would be data that lives on a laptop or on a server indefinitely after a research project is completed, and then just languishes there forever, and maybe if somebody asks after it, you'll go find it, but probably not. You want to have your data somewhere that's tracked, that can be easily obtained after a project is completed, so that it's not perpetually on you to keep migrating it and keep wondering about where it's going. You also want to keep track of versions. Most labs do not have a very sophisticated versioning system set up for data in progress, but we can help there, and there's huge benefits to being able to version your data, revert it, like code, go back and edit changes. Also, reproduce your work. There's increasingly many instances of old studies being debunked because the data was either falsified or just couldn't be adequately reproduced. We don't want this to happen, obviously, and reproducibility is a growing field, especially in biomedical research. Anytime that you can rerun your own analysis later on and have the same thing come out is great. Think of it like source code. Collaborate. The more people who can get your data, the more people who can actually work with your data. And of course, satisfy granting and journal requirements. This is a big one. It's coming up more and more often lately. The Tri-Council has a weak mandate in place currently, and there may be a stronger one to follow. We'll talk about that. And more journals are requiring data deposit, and a lot of those journals do not have the means to host the data themselves, so they're falling back on data repositories such as FERDR, Compute Canada's Federated Research Data Repository, as a means to locate data after an article has been published. So that's a requirement increasingly. We're seeing more and more faculty being mandated to deposit data, and we're happy to see it because we're trying to provide a good and easy means of doing that. There is a life cycle to research data management. It's not really set in stone. The source material I took this from actually has just create as the first step, and I wanted to expand that to create/discover. In the case of meta-analyses, but this is pretty familiar. You'll create some data, you'll process it, you'll analyze it, and then toward the end we think about preserving, sharing. The point with this RDM lifecycle image is in part to emphasize that preserving data is not just something that happens at the very end of a research project. If you haven't thought about preserving it from the beginning, it's going to be increasingly onerous to preserve toward the end. There might not be time left in the grant or money or graduate students on hand to preserve your data, and so again, it just winds up sitting around somewhere. So the earlier you're thinking about questions about RDM, the better, and the earlier you've got it tracked in some kind of reproducible system, the better. So one of our go-to solutions for thinking about data management is data management plans, or DMPs. DMPs are what they sound like. They basically ensure that you've thought about any concerns you might encounter around research data management as early in a project as possible, and so that you've thought about, you've mitigated future roadblocks by doing so. If you want an example of a very bad DMP, There's this great letter that we took off this blog where it says, "Dear NSF," the NSF being the National Science Foundation in the US, "I will store all data on at least 1 and possibly up to 50 hard drives in my lab." Not great. 1 is obviously worse than 50 because you want to have backups, but this is pretty close to the reality in many cases. The directory structure will be custom, not self-explanatory, and in no way documented or described. I think that part is actually quite close to the norm for many people. File and folder structures are never, ever consistent. It's an artifact of how we use computer file systems, and that is often one of the biggest obstacles to just understanding someone's data after the fact. And students working with the data will be encouraged to make their own copies and modify them as they please. Yep, that also happens. Again, we're not all working in the same version control environment often. And a lot of the efforts to use, Git for data or Git for non-code haven't really taken off. And so figuring out how we can still best scale our approaches to managing data in a way that works for most people is an open question in some respects, but there are best practices. So I'm going to do a brief demo of the Portage Data Management Planning Tool. If I search for the Portage network, what I get is this website, and this website is maintained by a working group of the Canadian Association of Research Libraries called Portage. Portage largely deals with research data and best practices. They provide input and steering and policy to FURDR, which we've mentioned, we'll get back to in a bit. And they also host an instance of this tool called the DMP Assistant. The DMP Assistant is a tool for managing research data. I'll just sign out so you can see what the sign-in mechanism looks like. It's pretty straightforward. This is hosted at the University of Alberta currently, and it provides a way of answering any questions that might arise around the storage of your research data. The logo right now is broken, I've noticed. They are in the middle of migrating this to a V2, so you might see some minor glitches, but they have committed to keeping it up while the V1 migration's going on. And I can start out creating a data management plan right here by just clicking on Create Plan. And I'm going to be prompted to select my organization. If I scroll down, there's a few universities in Canada that have provided their own specialized local guidance in cases where their own data reporting and management requirements differ from the national baseline. If we go to SFU, which is toward the bottom here, you'll see we also get the option to opt in to the Simon Fraser University DMP tool text. So I go ahead, create plan, the Portage template with SFU guidance, and you'll see here, here's the top level data for my plan. It's auto-filled my name, but nothing else, so I can fill in if I want to any of my grant numbers and researcher IDs and so on. And here we'll see an overview of the kinds of questions it's going to be asking. And these include questions about data collection, what types of data are you creating, data documentation, storage, backup, preservation, sharing, reuse, responsibilities and resources, and so on. A lot of the more interesting ones for me are questions about who will be responsible for owning the data over the longer term. In cases where you've got a cross-university or cross-national collaboration, which university's IP policies are you defaulting back to? Who owns the data longer term? Who's given consent to it being reproduced? Issues like that don't often get asked. And then the more obvious ones, like where are you going to store the data over the course of the research project, and where are you going to store it longer term? So a lot of these questions that we usually figure out as we go, but we could do with having a more systemic approach to. If I go through and click here on the questions, you'll see, wait for it, there we go. You'll see the ability to expand some of them and actually fill out some text. So if I expand here, responsibilities and resources, you'll see the questions, you'll see the Portage guidance, and in some cases, you'll see some additional SFU tool text that we've incorporated to suit the local circumstances. So here, what resources are you requiring to implement your plan? What costs do you anticipate having to pay? This is similar to a few years ago. We started talking about building in budgeting for open access publication, where open access publication started to cost additional funds, and people were having to ask for it in granting applications as it wasn't normally covered by their expectations of when a project would be complete. So same thing here. Are you going to estimate costs for research data management? You'll see the SFU guidance tooltip has pretty much just added our local email support address here, which is not nothing. It's basically a way of contacting us if you want any more information. If I expand a different section, you'll see, for example, documentation and metadata, questions about what documentation are you requiring, how are you capturing it, and what metadata standard are you using to document your data. And here we've got, again, the portage guidance, links out to best practices of the UK Digital Curation Center. And the SFU tooltip mentions that we tend to utilize DDI, which is a metadata standard commonly preferred in the social sciences for a lot of our data locally. We use a DDI codebook format to describe data, and they can use a portal like DataSite, which will also index some of those DDI standards in some cases. So a nice way to get best practices with some local guidance, and when you're done filling it out, you can export your plan in PDF format or any other format, and you can attach it to a grant applications or research ethics boards reviews that you might be undertaking. So you've got it in one place and you can refer back to it. You're not duplicating any documentation, and you're answering these questions at the earliest possible phase. We expect to see more uptake of this as it gets higher and higher on the list of Tri-Council priorities and as V2 ships, but it is fully usable right now. You can collaborate on a plan with somebody else and fill it out together. So if you're wanting your grad students to answer half these questions for you, that's totally fine. And it's a very useful tool for ensuring that you've asked yourself some of the interesting questions about data management at the get-go. And again, you can find that at portagenetwork.ca. Portage is a nice bilingual name for something. It's got a lot of meaning. It's very cross-Canadian, and it's the same in both languages. So talking about that research data lifecycle, the first phase obviously is create data. This is where you're designing your research, you're collecting your data, and you're capturing and creating any metadata. It's great to think about metadata at the get-go, especially if it's a matter of getting you in line with the disciplinary standards sooner rather than later. So you're not finding that you have to kludge it and that half your fields and things you've studied don't quite align with expectations. I am a librarian. I love metadata. It's a stereotype, but it's a true one. So I will talk your ear off about it any chance I can get. These are pretty prosaic questions, metadata, who, what, when, where, why, but then you start thinking about interesting cases for when and where might really get interesting. Does your metadata schema allow for geolocation? Are you measuring down to a certain number of digits of latitude and longitude? Or is it more relevant for anybody wanting to discover your data that you're storing a place name or a bounding box or a single point? Do certain metadata formats encompass that better than others? If we're talking about when, are you storing individual times for observations, or are you storing date ranges? If you're storing a date range, can you store that in two different fields, like you've got from and you've got to, rather than just having a single hyphenated field, which is going to be more difficult to split apart later? For who, it's pretty well known in computer science that you can't reliably disambiguate first names from last names if you've just gotten a single name field. Because of differences in cross-cultural first name, last name formatting, you can more or less never automatically split that apart to first name, last name from a single field. So if you've got any intention of wanting to separate last name from first name, two fields from the start, better metadata. So it seems obvious, but it's not, and people do kind of make these mistakes where they could save themselves some time later on. Metadata is really useful. As a rule, you're not going to remember what the variable mult_mgp represents. Talking about our weird expectations of computers, I feel like many of us just learned in the 80s that you have to name your file names with these really bizarre short abbreviations. It's like 8.3 DOS format. It's a weird habit that's persisted. We like to use a lot of very, very, very brief and borderline unintelligible abbreviations for things. But of course, without metadata, no one's going to know what that means, and you're never going to lose anything from documenting it. So depending on how you decide to name your columns in your spreadsheet or anything else, chances are your brevity is not necessary. You can make them longer, but if you do find yourself using any obscure or not immediately intelligible acronyms, document them separately. There's no harm ever in publishing a code book or a README, just explaining what all the different columns mean and how they can be used contextually. It'll save yourself time later. It'll save yourself time for anybody new coming onto your own project, and it'll be a massive help to anybody else using your research later on. We can think about multiple different levels of documentation. There's project-level documentation, which is like the abstract for the paper, and maybe your data set isn't one-to-one with the paper. Maybe you're producing multiple papers from one data set, and so write your data set its own abstract, right? Talk about what the data is used for, how it can be used by others. There's also file or database level metadata. So again, those files and folders, a lot of us use file systems in very idiosyncratic ways. And so you want to have some kind of systemic approach that can at least be explained to anybody else wanting to find your files. If you're uploading a zip file to a data repository, there's no harm in just putting in a little file that says, by the way, this folder contains X, this folder contains Y, this is pre-processed, this is post-processed. It's going to save tons and tons of time later on. And then there's variable or item level metadata, talking about that multi-MGP example from the last slide. Make sure all your column headings are explained away. Don't make anything needlessly contextual. It's very easy to explain things when you're doing them. It's very hard later on. We want to look at an example of some really good, like, gold standard metadata. Let's click through on some StatsCan stuff. This is from a 2006 census. This is hosted by the University of Toronto and OCL at Scholars Portal in their Odyssey platform. And here we're going to see like some real like Cadillac deluxe metadata. This is what StatsCan produces because they are funded to do so. It is their mandate to make sure that all of their metadata is as clear as possible. And so you'll see here, all this is pulled out. This is not just in the files themselves. We've got list of keywords, topic classification, universe of data, unit of analysis. These are all top-level categories for them. And they've ensured that they've contained them all in this data set. So talk about differences from the last sentence. This is basically a comprehensive list of errata. They've got frequency of data collection, for which they've listed, I love this, quinquennial. I think that means every 5 years. It would probably be easier to write every 5 years, but I still absolutely admire that as a valid response to that field. And they've talked about their sampling procedure, their mode of data collection, their weighting. All of this is in here, and you can even click through and you can click on other documentation. You get a link to a user guide or a code book, and that links to a PDF, which contains all the documentation for the 2006 census, and it is 150 pages long. So this is a pretty deluxe example, obviously used for multiple data sets, and it's used for pretty high-profile government projects. So we're not all producing metadata this comprehensive for all of our studies. One of the only research data institutes that I'm aware of that produces metadata that's comparable is ICPSR in Michigan. They are a social science institute, and they are committed to, for a significant amount of money, producing comparable metadata, subscription services, and so on. We often can't do that in academic libraries and at Further. We're doing usually a once-over, reviewing data for clarity, ensuring that we can figure it out, and we're generally not going to be able to match this level of comprehensiveness, but it's nice to see it. It's nice to be aware of expectations around metadata usage, and it might at some point be helpful to bring up our standards. They're closer in line to the StatsCan level of metadata documentation. That'll require funding. That'll require more work. That'll require more data curation, and that's something that we should be aware of and thinking about. So I will now hand off this presentation to my co-presenter, Adam, temporarily. Let me just stop sharing, and there I go.
Thanks, Alex. So I'm going to continue talking about past create data and more into the processing and analysis of data, first off. And so I'm just going to talk about kind of some of the best practices around that. So first of all, most of us will be normalizing or cleaning or doing some sort of process on our data to start with after we've created it. And for a lot of us, we'll be able to actually store a version of a raw copy of our data so that if we ever figure out there's a mistake in our process, or we need to reproduce something, or come up with a new process, we can still run it. And so for making a raw copy, a best practice is to mark it as read-only, so that you or others might not accidentally edit it, and so then kind of corrupt it so that you can't rely on it being how it was originally. This brings us into kind of versioning and some of the stuff that Alex has been talking about for file naming conventions to help you and your colleagues kind of use the same sets of data, you and your students. So it's important to have this kind of upfront and documented somewhere for your group so that everyone's kind of on the same page, so that if anyone ever has to share data or look at each other's data or or handoff data from one student to another, for example, that it's clear and understandable. So the first tip is to kind of keep under control the rest of this, is to keep the file and folder names short but meaningful, so that you don't go overboard and just add everything that's on this page. Not everything on this page is going to be applicable to you, for sure, but just keep that in mind so that it's not too onerous that you're not actually going to do these conventions, because it would take too much time. One thing we recommend is date formats be expressed as 4 digits for the year, 2 digits for the month, and 2 digits for the day. That'll help with sorting and finding your data later on. Sorting, because if you have the same kind of rest of the file name, you can actually just sort by the file name and it'll come out in the correct chronological order, either reverse or forward. And also, if you need to find a piece of data and you know it's here, you can easily search this format, and it's unambiguous about what's the day and what's the month, or even how many letters you're using to represent months, for example. We also recommend you don't just name it with just the document's title or just the data's name, so that it kind of makes sense in context outside of that folder. So for example, if you take it with you home and it ends up in a different folder by accident and you're not sure where it came from, that it doesn't take a lot of effort and crawling through to figure out where it needs to go. And then finally, we have some kind of different categories you might think about including in your file names for certain projects that might help you. Versions, which I'm going to talk about in a sec. Creation date, creator, description, research team, publication date, and project number. Those kind of details that will help you filter out files that you do or don't want to see. So for file versioning, if you're going to be incrementing something a whole bunch of times, particularly documents might be this way, or other data sets or that kind of thing, you could take a page of this software developer's book where major changes are denoted by a first digit, and then a period, and then the second digit is kind of minor changes, and then the third digit is kind of for fixes or bug fixes, spelling mistakes, that kind of thing. This helps you escape the inevitable definitely the final document naming of things. And if you have a standard, it's easier to figure out which document is actually the last version, irrespective of maybe an accidental edit that will move the last modified time ahead so that you think that that's the newest one when it's really not. Also, if you are using code, of course, Alex mentioned it earlier, Git can help you a lot by helping you track the version of your code and give you a way to kind of reference it with Git commits and that kind of thing, so that it'll help you with connecting data to the code that may have created it, processed it, cleaned it, that kind of thing. So I've got some examples of files on the right-hand side of the slide there. We've got Smith interview. Hopefully Smith isn't a sensitive information exposed in the file name. July, like I said, maybe August has 3 letters or all the entire letters. You need to have this kind of a standard to be able to search for dates. And then finally, version 1 draft, what's kind of illuminated by draft that's not illuminated by the version 1 is kind of difficult. The bottom one is a little bit better. It's got kind of the date format we recommend, but it's got some potentially incomprehensible acronyms. If this is the standard in your field, for sure, put them in there because it's short and it's meaningful to you. But if it's not meaningful to everyone, it might cause you trouble down the line if you move into a different project and you stop using those acronyms, particularly if they're a local one. Okay. So now you've got your data organized and named properly, and now we have to worry about storing it. There are definitely ethical implications to where you store your data, especially in terms of if it's personal identifiable information or part of a human results study. And then definitely in certain jurisdictions, be clear about whether you can actually store this information in the cloud. Some provinces don't allow you to do that without proper consent or with the Research Ethics Board knowing. So once you've got your data stored, you're going to have to regularly back it up, unfortunately. You're going to need, hopefully, in an ideal world, both on and off-site backups. What do I mean by an off-site backup? Let's say you have a disaster, like you've spilled your coffee on both your laptop and your external hard drive while it was backing up. That would take out your local copies, and hopefully you'd be able to recover it from an off-site copy. So that's something to think about as well. For securing your data, now that you have multiple copies of it everywhere, there's kind of 3 kind of layers I wanted to highlight today. There's the physical security of your data. If it's on a laptop or if it's on a thumb drive, can it be stolen? Can somebody access your lab to get access to that data? For computer security, is your antivirus up to date to protect you from malware that might encrypt your data? Are you using best practices for passwords? Can you use encryption on your laptop so when you take it out, it's a little bit safer? And then finally, there's kind of personal security, which is kind of a weird category. But for example, at the University of Saskatchewan, we're under increasing phishing attacks, where they send us emails that look exactly like official emails the university would send out with our banner and with people's names in there that match our institution, those kind of things. So always have our links to kind of verify that they go where you expect them to go. And then finally, if you have sensitive data that needs to be destroyed, just keep in mind that when you delete data, it isn't actually destroyed. Most file systems will mark it as available for reuse. And so if nothing actually overwrites that, it might be able to be recovered. So it's kind of the same concept of shredding paper documents. Speaking of sensitive data, you definitely will need a little more security for sensitive data, and it might help to be able to anonymize it. I'm sure ethics boards will recommend things like this, but creating lookup tables and keeping those lookup tables safe that identify the participants. Using disk encryption, like I mentioned, for laptops or thumb drives so that data doesn't accidentally get leaked. Having a schedule for retaining very confidential or sensitive files. This is on both ends, both so that you maintain it for the proper amount of time, and also so that you know when it's safe and when you should be destroying the data so that you aren't liable for keeping it for too long. And then finally, there's the possibility of aggregating the data to try to allow for sharing to hide kind of the sensitive information of the data, which might be in your field. So that's kind of working on data sets. So once you've kind of got data in the form you want it, we want to talk about the next part of the data lifecycle, which is preserving the data. And this is to kind of ensure that the data is available for a longer term than just right now. So part of this might be migrating to new formats, which I'll talk about in a sec. But also it might be, you might need a lot of the metadata Alex talked about to make sure that it makes sense to yourself and others in the future. And then finally, you might want to think about ways you can bundle it together so that if you had a schedule to check it, that you can check it for completeness and you can check it for correctness later on. Might be some principles you have to accomplish. So for file formats, ideally you want to use a file format that's commonly used. For example, everyone uses MP4 practically for videos. Everyone uses docx for documents. The more safety in numbers, the better. Ideally, though, you want to use non-proprietary formats so that there's a community of people that know how to read these formats and so that they might be available longer term. Just to give an example, WordPerfect kind of disappeared, and so it's very difficult to open WordPerfect documents now. But docx, for example, there are open source solutions that will still open them. And so it's kind of non-proprietary, still proprietary, so just be aware of that. And then finally, if you are going to encrypt your files, definitely have a process or a plan for how you're going to keep those keys and files available long-term. Next up, I'm going to talk a little bit about sharing data. So now that you've got it preserved and you've got it created, and if you want to share it with your colleagues or local group or abroad, there's evidence that shows that sharing may increase citation rates. There was a study that examined citation history of 85 cancer microarray clinical trial publications. 48% of trials publicly available with this data received 85% of the citations. Publicly available data was significantly, p-value of 0.006, associated with a 69% increase in citations, independent of journal impact factor, data publication, and author country of origin using linear regression. So there's kind of some good results there. It's good from authenticity to also show your null results. It's ideologically good, which we'll talk about in a little bit. And it could also raise your scholarly profile and increase research impact, because now people can also both cite you for your papers and for the data sets you've created and shared. So how do you go about sharing? One major way we've kind of talked a little bit about is through research data repositories. And basically these are websites that you can post your data to that will manage it and take care of it for you, that you'll be able to reference so that people can find it there, either journals or other colleagues or that kind of thing. There's kind of some different dimensions to them. For example, there are institutional repositories and subject or domain repositories. Some institutions will run their own research data repositories that are available to their researchers, so you'll have to contact your library to kind of find out kind of what options are available there. There's also domain repositories, which, for example, like if you're in astronomy or medicine or social sciences, perhaps in your field, there's a go-to solution there. There's restricted use versus on-demand use for data. On-demand means that the files are downloadable by anyone. Maybe they have to sign up for an account, but it's easy to download. Versus restricted use, there might be a process participants have to go through to actually get the data. There's also curation levels for different repositories. There's some repositories that will allow you to deposit your data set that will then be available just like that. Also, there's others where there will be a curator who will walk you through the whole process of looking at your data and trying to make it more understandable by third parties so that it's might make more of an impact. And then finally, some repositories offer persistent identifiers. An example of these is DOIs. You might have heard of those for papers, where basically you get a URL that points to the location of where your data resides. And this can be updated in case the data ever has to move or go offline for a period or whatever, so that you can safely put that in a paper and know that it's going to be available years down the road, not just right now. Okay, so I'm going to demo quickly the project that Alex and I work on. It's called FRDR. It's the Federated Research Data Repository. That's a repository that we kind of tried to build to support very large data sets. And so if you were to search FRDR on Google, you'd end up with this particular website here. So we can actually go ahead and search for some data here. So I'm going to search for Jasper and find this kind of search results over here. And then click on this top data set here, and it would pop up what you would normally get for depositing to a data set to a repository. You kind of have some descriptive metadata. You've got the title. You've got a description that gives some of the history of the data set. You've got the authors that are involved so that you can cite them. We've got keywords to improve discoverability. We've got the data was published, some related URLs to find more information about the data set, who created it, what other data sets they have, that kind of thing. And then down here we've got some structural metadata, which is more just the file names and structure of the directory. So clearly this data set is about Jasper National Park. And so if you were to download this into your downloads directory, it would be very clear what it is alongside all the rest of your directories. And inside there, we've got some dates, we've got some locations, and then we've got master versus raw kind of data sets. So it kind of gives you a lot of information just based on file names and folder names. Down below, we've got some administrative metadata. We've got the license that's available under, how to contact the people responsible for the data, and then some easy ways to get citations for the data itself. Okay. So kind of the concept of sharing data through FRDR is kind of, we try to encourage open licenses so that the data can be reused, not just viewed. We also support embargoes for data. So say you have a publication coming out and you'd like to put the data set DOI inside that publication, you could send the data to FRDR. We could keep it secret just to you until that publication is available, and then release it at that time. This could also be for PhDers who are just finishing up and they're wanting to publish a data set after they're done, that kind of thing. Okay, so we've mentioned kind of the tri-agency's principles on digital data management a little bit here. So we've got kind of some of their statements and just some bullet points from their recent statements. We've got, and just listen to these to see kind of how you feel about them. The agencies believe that research data collected with the use of public funds belong to the fullest extent possible in the public domain and available for use by others. Researchers are responsible for incorporating data management best practices into their research, developing research data management plans to guide their responsible collection, formatting, preservation, sharing of their data throughout the entire life cycle of a research project and beyond, following the requirements of applicable institutional and/or funding agency policies and professional or disciplinary standards, acknowledging and citing data sets that contribute to their research, and staying abreast of standards and expectations of their disciplinary community. So this seems to be the direction they're heading. They haven't made any direct demands quite yet, I don't think. There are definitely some challenges that can come with sharing data for sure. If it's sensitive information, there might be legal or ethical limitations about sharing the raw data files. You definitely have to evaluate your data on a case-by-case basis. And of course, anonymization could be a solution. Exploring sharing a little bit further, I want to talk about an organization called DataCite. So they're responsible both for DOIs and the DDI metadata standard Alex was talking about. For DataCite, they have kind of two services down here at the bottom. One is to search for data sets that have been listed with a DOI, just to give you kind of an understanding about how DOIs work. The other one is that they have a list of all repositories that they know about. And so if we go to their dataset search and search for Jasper, we find kind of all the data sets that match that for the metadata. And down here we find the same data set we were talking about earlier. It has the DOI here that you'd be able to put in a paper. And then this points to where the data currently resides. So that's kind of how a DOI works. And then on the other side, they've got their RE3 data, Registry of Research Data Repositories. This could be a tool to help you find research data repositories to deposit to if your colleagues don't have a go-to solution. So basically, we could search something like radar, and that would both find us SuperDarn, which is an astronomy kind of domain-based research data repository that would have metadata that would apply to them, as well as down below here we have Alex's SFU radar, which is where an institutional repository where SFU researchers can deposit to. So as the Tridence mentioned, citation is essential. It's basically just like citing a paper. Creator, publication year, title of the data set, version, publisher, resource type, and identifier for all those kinds of fields. And it's pretty easy to find on Google how to cite data in all the different formats. Okay, and I'll pass it back to Alex.
And there we are. Thank you, Adam. It was a pretty well-timed handoff. I think we're getting good at that. All right, so I just want to speak for a few more minutes about unique challenges around sensitive data. Sensitive data, for our purposes, is any data that involves human subjects or animal subjects, data that was generated or used under a commercial research funding agreement, so anything where a private organization may have a stake in the data set, or data that has potential to have significant negative public impact and should not necessarily be shared. We obviously want to share data, but we recognize it's not always possible in all contexts. And the tri-agencies also feel likewise. They do have this boilerplate addendum to their baseline statement saying that researchers should also consider whether any ethical, legal, or commercial obligations prohibit sharing or preserving the data, or whether any of the data need to be de-identified or made available with restricted access. That word de-identified is actually a key one. It's not always sufficient just to anonymize data. De-identification can be much more complicated than simply removing names from a data set. Talking about ethnography specifically, because that's typically a field that has exclusively human subjects data, ethnographers are generally in favor of making their audiovisual recordings available whenever possible. There is this tension, right, where we see that it's a public good, we want to be able to share data, we believe that that is adding value in all cases and making research richer, but it's not always possible, and it's impossible flat out if you have not obtained permission for sharing during the initial informed consent process. And this is a really key point. You typically cannot return to your informed consent agreement. You can't go back to all of your initial study participants. It's a study of any size. You can't revise that. You only get one chance typically to ask permission for anything you're going to do with a study participant. And sharing has to be included in that. If you have any intention of anonymizing and making the data available, you must include that in your initial informed consent statement. And ethics boards are getting better about reminding researchers to do that. We've had a pretty good job of communicating upstream requirements there, but it really should be emphasized that that has to be an early stage consideration, or else that data set cannot be shared. We've got an interesting case study of reuse that we like to point to talk about the kind of innate good of reusing data. There was some recent research done about 10 years ago by a researcher named Clarence Gravely that wanted to revisit some of the earliest anti-eugenic studies, basically disproving a lot of the work done around racial differences, and he wanted to make sure they still held up. He wanted to ensure that these studies could be validated, that we could still point to them and see that they still work nowadays, because they were respected, but I think there are people who are wanting to cast doubt on them just due to the age of the work, and wanted to make sure they're methodologically sound. And so Clarence Gravely in 2002 and 2005 went over these original data sets, which had been printed out and in many cases handwritten. I think, actually, no, sorry, it was always handwritten, 1915. Always handwritten. That's my assumption that all data is connected digitally nowadays. And he went back and they manually input them into statistical data software. Typically, OCR on tables is functional, but not great for handwritten data. If anyone's curious, there is a pretty good open source platform called Tabula, which can help you scan and OCR tables, but it will fall down on handwriting. So this involved a lot of manual correction. And because the data was included with the initial paper, Gravely and his co-authors were able to go through and affirm the original findings and substantiate them with more modern methods. So we do like to tell people, don't print out your tables, put your tables in a data repository. They're more useful in raw format. But in the 1910s, printing out the tables, sorry, I said printing again, writing them down was just as well, and including them with the paper was sufficient for a determined researcher to be able to digitize them and reanalyze them. So when you are creating data, you should always think about ways to make your data legible and meaningful to others beyond yourself or your research group. This can be at odds with anonymization. If you're surveying very small groups, if it's a geographical study and your data is quite granular, if you're looking at, only women, only in a certain income bracket, only in a certain location in a city, re-identifying participants may be possible. Postcodes get pretty granular. And so for StatsCan data sets, in some cases you will see that the public use data has had some of their very small cells and very small study groups expanded, and they've taken out some granularity in what they make public. There's nothing wrong with making a special restricted use copy of your data set or making a derivative for public use and storing a different copy with full granularity so you don't actually sacrifice that, you just don't make it available. That's fine. It should be something that is considered. I've heard a rule of 10, basically, where if you have any given identifiable group, any cell of your data set contains 10 or fewer participants, you should err on the side of growing your studied population, collapsing some granularity so that you never have 10 or fewer people in any given set. That's not a hard rule, but you want to make sure that you're not creating the potential to re-identify data, especially if you cross-reference with other public data sets. So we've got some acknowledgments for this section of the talk specifically around human subjects data, but otherwise, that brings us to the end of our slides, and we are really happy to take questions. I already took a couple in the chat, but I'm really happy to answer any more. So thank you. And do we have any questions? I saw a link to a scalable relational database service that was posted by Adrian here. This is apparently a research database solution that's offered by Case Western, and it tries to make really simple database design and programming available to research groups. This is a great service. Databases are hard to scale, like I mentioned in the chat. There's just not the expectation that most smaller labs that don't have their own sysadmin will be able to run Postgres and be able to work this way. And even being able to explicate database design to people who don't have someone to talk to about it usually won't get you very far. This apparently used to be a more popular category of software. There used to be relational databases for desktops like in the 80s and 90s, and there aren't anymore because we've all scaled up to servers, which is good from a maintainability perspective, but it does mean that, you know, most people's common denominator, their lowest case flat file solution is Microsoft Excel. And so we'd love to make a service like this more widely available. We haven't tried to scale anything like this out of Compute Canada, but it's something that we would actually consider, both at SFU and Compute Canada. So we'll see if there's sufficient need for this. I would want to look into it in the future. It's a good idea. We've got a question from Brandon. Is it encouraged to use space on Cedar for offsite backup? Adam, you can take that.
It depends. So definitely a project is meant for not fast processing, so it kind of depends on your data set for how, yeah, it's probably a good solution. There's a nearline solution coming hopefully soon where we'll have tape backup available for kind of offsite backup purposes, but for now I think project is probably your best bet at Compute Canada. And definitely don't use Scratch, as it's both fast and it's cleared off regularly, so not suitable for backup. Home is fast, but it's quite small for most allocations, so project is definitely where you'd want to be there.
I'm not hearing any other questions, so thanks everyone for being here today. If you have anything else to ask, you can follow up. We've got our email addresses on the slides right here. I'm just garnet at sfu.ca, and Adam is adammckenzie at usask.ca.